In episode 96, titled Association Rules, Support, Confidence, Lift, and Practical Meaning, we focus on a style of analysis that is less about predicting a numeric outcome and more about uncovering patterns of co-occurrence that can guide decisions. Association rules are often introduced through market basket analysis, but the same ideas apply to security events, user journeys, operational sequences, and any setting where the question is, what tends to happen together? The challenge is that association rules can produce an overwhelming number of patterns, many of which are trivial, noisy, or misleading if you interpret them too literally. To use them professionally, you need to understand the core metrics and what each one actually tells you. Once you have that, you can separate meaningful associations from patterns that merely reflect what is already common. This episode builds that metric intuition so you can read rules, explain them verbally, and connect them to action without falling into classic traps. Before we continue, a quick note. This audio course is a companion to the DataX books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.me in the Bare Metal Study Guide series. Support is the simplest and most foundational metric because it measures how often the items in a rule occur together in the dataset. If you have a rule that says item A implies item B, support refers to the fraction of all transactions, baskets, or events in which A and B appear together. Support is therefore a prevalence measure, telling you how common the combined pattern is in the population you observed. A rule with very low support might be interesting, but it is also more likely to be unstable because it is based on a small number of observations. In practical terms, support helps you avoid building conclusions on rare coincidences that happen once or twice and then never again. It also helps prioritize patterns that matter at scale, since a rule that appears in a meaningful fraction of cases has more potential impact. Support is therefore both a filter for reliability and a proxy for how much volume a rule could influence. Confidence is the probability of the consequent given the antecedent, meaning it tells you how often the rule's right side appears when the left side is present. If the antecedent is item A and the consequent is item B, confidence is the fraction of cases containing A that also contain B. This makes confidence feel predictive because it answers a conditional question. When we observe A, how likely are we to observe B as well? Confidence is often the first metric people gravitate toward because it seems to capture the strength of the implication. However, confidence depends heavily on how common the consequent is overall, which can distort interpretation when B is naturally frequent. A high confidence value can therefore reflect a real association or simply reflect that B appears in many baskets regardless of A. Understanding confidence as a conditional probability, not as a measure of surprise, helps you interpret it properly. Lift is the metric that corrects that intuition by comparing the confidence of a rule to the baseline probability of the consequent. Lift can be described as how much more likely B is when A occurs, compared to how likely B is in general across all cases. A lift of 1 indicates no improvement over baseline, meaning A does not change the likelihood of B relative to the population rate. A lift greater than 1 indicates that B is more common when A occurs than it is overall, suggesting a positive association beyond baseline prevalence. A lift less than 1 indicates a negative association, meaning B is less likely when A occurs than it is overall. This baseline comparison is why lift is so useful, because it distinguishes rules that are merely confident because the consequent is common from rules that actually indicate a meaningful change in probability. Lift makes the rule about deviation from expectation rather than about raw conditional frequency. High confidence alone can be misleading when baseline is high, and this is one of the most common exam-level pitfalls. Suppose the consequent is something that appears in most baskets, like a popular staple item or a common event in a system log. A rule that predicts that common item will naturally have high confidence even if the antecedent provides no meaningful information. This can create a false sense of discovery, where the rule appears powerful but is actually just describing what happens most of the time anyway. In business terms, such a rule is often not actionable because it does not identify a special condition that changes outcomes. This is why you should treat confidence as incomplete without considering baseline rates. If you remember that confidence can be inflated by common consequence, you will naturally reach for lift to answer the more important question of whether the rule adds information. Using lift to detect meaningful associations beyond common items is therefore a disciplined practice rather than an optional detail. Lift highlights rules where the antecedent genuinely increases the likelihood of the consequent relative to baseline, which is closer to what stakeholders mean when they ask for patterns. In market basket terms, lift helps you discover combinations that occur together more than you would expect if items were independent. In event sequences, lift can reveal that certain alerts occur together more than their individual frequencies would suggest, which can guide correlation or triage workflows. Lift also supports ranking, because rules with similar confidence can have very different lift depending on baseline prevalence. That ranking matters because operational attention is limited, and you want to spend it on patterns that are both reliable and non-trivial. Lift is not perfect, but it is a valuable check against being impressed by the obvious. Reading market basket and event sequence scenarios verbally is a skill because many questions will describe a situation in words and expect you to translate it into what the metrics mean. In a market basket setting, a basket is simply a set of items purchased together, and a rule says that when some items appear, another item tends to appear as well. In an event sequence setting, the basket might be a time window or a session, and the items are events or alerts that co-occur within that window. The mechanics are the same even if the domain differs, because you are still counting co-occurrence patterns across many cases. Practicing the verbal translation means being able to say, in plain language, how common the combined pattern is, how likely the consequent is when the antecedent is present, and how much that likelihood differs from baseline. If you can explain those three statements, you can usually reason correctly about support, confidence, and lift in almost any scenario. A crucial discipline is avoiding interpreting association as causation, because association rules describe co-occurrence, not cause and effect. A rule that says A tends to appear with B does not mean A causes B, and it does not even mean A precedes B unless the data representation enforces sequence. In market baskets, two items may be purchased together because of a third factor like seasonality, promotions, or household size. In security events, two alerts may co-occur because both are triggered by the same underlying system change rather than because one alert causes the other. Treating association as causation can lead to incorrect interventions, such as changing one element and expecting the other to change. The safe interpretation is descriptive. The pattern appears together more often than expected, which can be useful for recommendation, bundling, triage, or investigation. Keeping this boundary clear protects you from overclaiming what the metrics actually support. Choosing thresholds for support and confidence is necessary because association rule mining can produce a huge number of low-quality rules when you allow rare patterns and weak implications. A minimum support threshold filters out extremely rare item sets,
reducing the chance you chase coincidences and improving the stability of rules over time. A minimum confidence threshold filters out rules that do not provide meaningful conditional probability, reducing the number of weak implications. These thresholds are not purely technical because they reflect the balance between discovering niche patterns and maintaining reliability. If your thresholds are too low, you will be flooded with rules that are hard to validate and unlikely to generalize. If your thresholds are too high, you may miss specialized but valuable patterns, especially in niche segments or rare event contexts. The professional stance is to treat thresholds as a noise control mechanism, adjusted to match data size, business needs, and tolerance for false discoveries. Sparse baskets create a special challenge because when transactions contain very few items, co-occurrence counts can be low and unstable, making it hard to find reliable rules at a fine-grained item level. In such cases, focusing on frequent patterns and categories can help, because aggregating items into higher-level groups increases support and improves stability. For example, instead of mining rules about individual rare products, you might mine rules about product categories, which appear more frequently and produce more reliable co-occurrence statistics. In event data, instead of using every specific event code, you might group events into families like authentication anomalies or file access anomalies. This aggregation is not about hiding detail, but about aligning the granularity of the rules with the density of the data. When baskets are sparse, overly granular rules tend to be unreliable and noisy. A category-level approach can preserve actionable insight while reducing the fragility that comes from counting rare combinations. Even when rules are statistically interesting, they must be evaluated for business actionability, because the purpose of association rules is to guide decisions, not to fill a report with patterns. Actionability asks whether the rule suggests a change you can make, such as a recommendation, a bundle, a triage shortcut, or an investigation lead, and whether the expected benefit outweighs the cost of acting on it. A rule with high lift might still be useless if you cannot influence either the antecedent or the consequent, or if the discovered association does not translate into measurable value. In security, a rule that certain alerts co-occur might be actionable if it helps analysts prioritize or correlate incidents, but it may not be actionable if it merely reflects a noisy logging quirk. Actionability also includes operational constraints, because a rule that triggers too often may overwhelm teams even if it is correct. The best rules combine reliability, meaningful deviation from baseline, and a clear path to action. Patterns change over time, so documenting rule constraints and monitoring is part of using association rules responsibly. Documentation should capture the definition of a basket or time window, the thresholds used for support and confidence, and any constraints applied to restrict the search space. Without this, rules can be regenerated later under slightly different settings and appear to change dramatically, creating confusion about whether the environment drifted or the process did. Monitoring matters because associations can drift as customer behavior changes, product catalogs change, attack patterns evolve, or system instrumentation changes. A rule that was valuable last quarter might become irrelevant, and a new association might emerge that requires attention. This is why association rules are not a one-time discovery exercise, but a pattern maintenance task if they are used operationally. Treating rule mining as an ongoing process keeps insights aligned with the current environment. The anchor memory for episode 96 is that support counts, confidence predicts, and lift compares to baseline. Support tells you how common the joint pattern is, which helps you judge reliability and potential impact. Confidence tells you how often the consequent appears when the antecedent is present, which supports conditional reasoning and simple prediction. Lift tells you whether that conditional probability is meaningfully different from what you would expect given the consequence's baseline prevalence. Holding these three roles separately prevents many common misinterpretations, especially the tendency to overvalue confidence when the consequent is already common. It also gives you a clean way to explain rules verbally to non-technical stakeholders without losing precision. When you remember this anchor, you can interpret association rules quickly and correctly, even under exam pressure.
To conclude episode 96, titled Association Rules, Support, Confidence, Lift, and Practical Meaning, choose one rule metric to prioritize and explain why, because different contexts demand different priorities. If you must prioritize one metric for discovering non-trivial associations, Lift is often the best choice because it explicitly accounts for baseline probability and highlights patterns that add information beyond what is already common. This is especially important in domains where some items or events are naturally frequent, because confidence alone will produce many rules that simply restate that frequency. You would still enforce minimum support to ensure reliability and use confidence as a sanity check for conditional usefulness, but Lift would guide which rules you treat as truly meaningful. Prioritizing Lift also aligns with actionality, because a rule that changes probability meaningfully is more likely to support a decision than a rule that is merely common. When you can justify that priority in terms of baseline comparison, you demonstrate you understand the practical meaning of association metrics rather than just their definitions. Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.